In this video, I'm going to be doing a quick review of power functions and their graphs and what they look like when they're graphed. A power function we define in the standard form as f of x equals kx to the power of p. K is our coefficient, right? And p stands for power, the power that we're raising the variable to, right? Well, how is f of x equal to 1 a power function if there's no x to the power of something? Well, technically, you could say that there's an x to the power of 0 there, right? Anything raised to the power of 0 is 1. So if we were to graph f of x equals 1, it would just be that straight line right there, right? Because it would just always be 1 forever in both directions. Positive 1. All right, for the next one, f of x equals x. Well, that's x to the power of 1, right? And for all these, our coefficient is 1. But yeah, I'm getting a preview of what each graph would look like. So f of x equals x, just a diagonal line going right through the origin, right? Because it's just mx plus b, just without the b, right? F of x equals x squared. We all know that one, right? Parabola. Looks like that. All right. Now, it's the one you may not know, x cubed. What does that do? Well, I think if you started plugging in values, you'd find that x cubed just goes up a lot faster than your regular parabola. But it does something strange here when it comes down. I may have drawn this a little too steep here. Well, not steep enough, because it really goes up really fast, right? But when it gets down here to, say, 1, it kind of tapers off. It goes through the origin, goes all the way to 1, and then takes off in the negative direction. Now, why is that? Because when you multiply a negative by itself 3 times, the answer will come out negative. So, just kind of doing dance there. What about f of x equals 1 over x? That is very interesting because you can't have 0, right? So we have an asymptote here. Can't divide by 0. So what do we do? Well, I think if you plugged in values, you might find kind of starts very square. But as your x value gets larger, you'll get closer and closer to 0 on the y-axis. And if you get really close to 0 with all these fractions, you're actually getting much, much larger number out of it. So you're getting closer and closer to positive infinity on the y-axis. And it's the exact opposite on the negative side. So 0 gets really, really low y value, and really, really low x values over there. You can say that x-axis is also kind of an asymptote, horizontal asymptote. Yeah, that's what 1 over x looks like. 1 over x squared. I'll just, what would that do? Well, still can't have 0, but something changes here. It goes a little faster, but still makes the same, pretty much the same shape there. But we don't really go into the negative quadrant. We go into the negative positive quadrant instead. Why is that? Because you put in a negative down here and it gets squared, it becomes positive. And that's how that works. All right, let's do these last two. Square root of x. Plug in a 0, you get 0, right? Plug in a negative, you get imaginary numbers. So there's nothing to the left of the y-axis. Absolutely nothing there. But as our x value gets larger, so does our y value, but very slowly. That's why it seems like it's kind of a half parabola there. Interesting. What about the cube root of x? Well, when you take the cube root, you can have negative numbers. So what happens? Still slowly gaining ground there, but we're also going that way, because when you put a negative in there, you can still get a negative out. So those negatives keep piling up, but very slowly on the y-axis side anyway. And the x-axis side is very fast, greatly increasing. Make sense? Thank you for watching.